This lesson is going to teach you how to convert from grams to moles and moles to grams. What you'll need for this lesson is a periodic table, your calculator, and I have a few examples. So we'll take this example right here, 50 grams of C6H14. What you need to remember is that when you start in grams, in order to convert to moles, you do need to calculate your molar mass from the periodic table. So first you can start by calculating the molar mass, C6H14. You have 6 carbon and 14 hydrogen. When you multiply and add those together, you get the molar mass is equal to 86.2 grams per 1 mole. And if you still need practice on molar mass, please review the molar mass video. To set up this equation, we're going to use dimensional analysis, although you're welcome to use proportions as well. Setting up dimensional analysis, I'll start with what I'm given in the upper left, grams of C6H14. I'm going to make a T-chart. And the focus for dimensional analysis is being able to cancel out the unit from top to bottom. So when you're looking at this equation, this is all over 1. What information I have is grams per 1 mole. In order for grams to cancel out, I need to put 86.2 grams of C6H14 on the bottom and 1 mole of C6H14 on the top. This will allow me to cancel out the units and correctly multiply and divide. When the values are next to each other, you multiply, so 50 times 1, and then you divide by 86.2, leaving you at 0.58 moles of C6H14. It's a good habit to use the full unit, including the actual molecule or compound. All right, let's do one more. Let's look at 30 grams of lead 2 iodide. So in order to actually proceed, we need to make sure we write that in formula. So lead 2 is Pb. It's got a +2 charge. Iodine has a -1. So when we cross that down, we get PbI2 for that formula. We're starting with grams, and I'm asking you to find moles. So if that's the case, you need to be able to calculate molar mass. You have 2 iodine and 1 lead, leading you to an answer of 460.99 grams per 1 mole. Again, if you need practice with molar mass, please review the molar mass video. Your starting material is 30 grams of Pb, lead 2 iodine. You're going to make the T-chart. You're going to have 1 conversion, so we only have 1 area here. We know this is grams per 1 mole. In order for the math to work out, we have to cancel the units, so we'll place 460.99 grams on the bottom of our lead 2 iodide and 1 mole of lead 2 iodine on top. Again, that's coming from our unit. So then we can cancel out our grams, and we know that we've had the setup correct. We'll do the math by multiplying 30 times 1, dividing by 460.99, and that gives us a decimal value of 0.065 moles of lead 2 iodide. All right, let's do the reverse. If I gave you the actual moles, and I wanted you to convert into grams. So again, in order to do that, you will need to use your molar mass. So if you need to refer back to your molar mass video of how to calculate molar mass, please do so. Let's do a couple of these examples. So here we're starting with moles, and I want you to convert into grams. Let's start with this one right here. 5 moles of silver nitrate. You need to know that silver is a +1 charge, nitrate's -1, and our formula looks like this. We then calculate our molar mass, and our molar mass using the periodic table of these 3 elements. Don't forget that 16 times 3 here. We get a total of 169.88 grams per 1 mole. So now our starting material is moles, or our moles rather. And we have silver nitrate. So we'll start it off with a T-chart. We'll put a 1 under here. So because it's moles on top, we need to make sure that we write our 1 mole of silver nitrate on the bottom, because our goal is to be able to cancel out the units. Notice that we can either write out moles or you can shorthand MOL. So I'll write the value on top of grams. I've canceled them out just to ensure that I'm left with grams. What's on top you multiply, and then what's on the bottom you divide, giving you a total of 849.4 grams of silver nitrate. Let's do one more where we're converting from moles to grams. Again, this is a conversion from moles to grams. So let's do this last one here, 1.20 moles of magnesium hydroxide. I need to make sure I write my magnesium hydroxide correct. Magnesium is a +2 charge from the periodic table. Hydroxide is a -1. I put my parentheses on, I cross down the 2, and our formula looks like this. My starting material, written here, magnesium oxide. I write a T-chart. We can first calculate our molar mass before I go any further. So magnesium hydroxide, this gets distributed to hydrogen, and the 2 gets distributed to oxygen, and magnesium, I have 1 of that. The molar mass is 58.33 grams per mole. I'll then place the 1 mole on the bottom of magnesium hydroxide because I have moles on top and I need to cancel that. I'll put a 1 there just as a placeholder, and I'll put the value in grams of magnesium hydroxide. Cancel out my moles, and mathematically I multiply the 2 and I get the answer of 69.996 grams of magnesium hydroxide. It's a good habit to use either, in this case we only had 1 because it was a different value at the second decimal value, but it is a good habit to not round up, but if you want you can truncate either at 2 decimal values or at 3 decimal values.